Today let's talk about the lifetime of a job in a batch system. Turns out that a job in a batch system has a little more complicated lifetime than just running a program on your computer. When you run a program on your laptop computer, you start it, it runs, and it's done. But in a batch system, we have to worry about all the other users in the system, as well as also the mechanics of getting the job on and off the cluster. And so the lifetime is a little more complicated. What I'm going to do here is draw a timeline where this is time going forward with all the events in the life of a job. So the first event in the lifetime of a batch job is that the job is submitted by the user into a queue. That's when you sit down and type submit or queue sub or something along those lines. And that will go into the queue. And the job doesn't run right away. It's going to sit and wait in the queue for a while. This could be because there isn't a machine available for it to run. Could be that there are some more important users that have to be served. Could be a lot of reasons why it might wait for a while. But eventually the system will decide to run it. And so it's going to take that job and place it on a machine and have it start running. So now the job will be running for a while. And it's a batch job, so it could take a long time, might be hours. And ideally, it will run to completion and then just be done. But because, as we know, a cluster is a potentially unreliable system and bad things can happen, it's entirely possible that that job will fail or otherwise be removed from the machine. And this event is known as a preemption. That could happen if the machine fails, could happen if it loses power. It could be that a more important user has come to the system and the batch system has decided to preempt one job in favor of another. So if that happens, then the job will go back into the queue and wait for another machine to run. So this is more queue waiting time. But eventually that job will have its turn to run, so it gets assigned to another machine. It runs. And let's suppose that the job is lucky this time, so it has a good uninterrupted running time, and eventually it completes. And when a batch job completes, we can't just throw it away. We need a way of informing the user that it is complete and giving them an opportunity to see that it is complete. And so the job will typically wait in the queue in a completion state for a certain amount of time until the user recovers it. So we have more wait time here. And then at some point, the user will remove it. Now, looking at this timeline of a job, there are several measures of performance that we could consider. One is the time from which the user submits the job to when it is finally completed. And this is probably the time that the user is most interested in. This interval of time is known as the turnaround time. For most users, they care about when they get their results, and that's it. Now, sometimes it is useful to think about how long before the job actually receives some service by running on a node. And this is known as the response time. We also might care to know how long did this job actually run once it was placed on the cluster. Now, this is a little more complicated to answer because there are several ways we might define running. One definition of runtime would be to say, what is the time from the beginning of a successful run to its completion? So we might say it's this bracket of time here, which I'll call the actual runtime of the job. On the other hand, we might say, you know, that job was on the cluster for at least 2 intervals. And so the amount of time that it actually consumed from the system was from here to here, and then again from here to here. So we'll mark that as time consumed. Now, the difference between those two is kind of interesting, because of course this is what the user actually cares about, and ideally the job would use its actual runtime first. But the reality is, because of the preemptions, it consumed more time on the cluster. And in fact, this interval here that it consumed was not actually productive for real work. It ran and then it failed and we had to run it again. Whereas this interval here was useful for good work. So we have names for those as well. We'll call this area of runtime the good runtime, and this over here the bad runtime. Obviously, the good runtime contributed to successful results coming out of the cluster, whereas the bad runtime consumed resources, but it didn't actually contribute to useful results.